All right, starting with Unit 10, number 7. Don't forget tonight's assignment is Unit 11, 21 through 24. Adam, turn around, please. All right, do you guys remember from this unit what happens with negative exponents?
Go to the bottom.
They go to the bottom, and what if they're already at the bottom?
They go to the top.
They go to the top. All right, so the x squared, the very first term at the top, x squared, does it move or stay? Okay, what about the x to the negative third? Move or stay?
Go up.
It moves up, x to the third. And what about these two? Because they're both negative, what are they going to do?
Switch.
They're going to switch. All right, so y to the sixth over y to the fourth. And when you move things up and down, the negative exponent becomes positive. Who can tell me why the y's flip-flopped but the x's did not?
Because both y's are negative.
Because both the y's were negative, where with the x, only one was negative that moved up. Do you guys agree? Yeah. All right, put your phones away.
Phones away.
Okay, so we are going, I'm going to write up here really quick. When I have x squared times x cubed, when I'm multiplying like bases, what do I do to the exponent? So it's x to the fifth. All right, so we add exponents when we're multiplying like bases. But the bases stay the same, x and x and x. So if these were 5s, it would stay 5. If these were 7s, it would stay 7. I need you guys to stop. All right, the other one you need to remember is x squared raised to the third. What about that one? Do we add or multiply? Multiply. So it's x to the 6th. And the last one, x to the 8th over x squared. Add, multiply, subtract, divide. What do we do? Subtract. We don't divide. 8 take away 2 is what? So know when you are multiplying, when you are subtracting, and when you are adding. Okay. With that being said, what do I do with these x's? Add, subtract, multiply, add. So it's x to the what?
5th.
X to the 5th. And then here, what do we say we do with these here?
Subtract.
Subtract. And when we subtract, we have to look at where there's more at. Is there more at the top or more at the bottom? Top. So when I subtract, what's 6 take away 4? So it's y squared. X to the 5th, y squared. Questions on that one? No questions? Are we good? All right, letter B. I do have a power to a power here. Do you guys see that? Okay, so I'm going to circle this piece right here. What about out here? Is there a power to a power? Yes or no? No, but do you agree that's b to the first power? Okay, out here, is there any power to a power?
No.
Are there any like bases? All right, please stop. I am going to distribute this exponent here. But you do have to remember what little powers are on the negative 2 and the a that we don't see. There's a 1 there and a 1 there. Do you guys remember that? Okay, the a cubed b negative 7 is staying. There's nothing to do there. Okay, and then here, don't forget when we do negatives, I put them in parentheses. What's 1 times, there's a 3 right there. What's 1 times 3? So it's to the third power. B to what power when I multiply, I'm sorry, A. A to what power when I multiply the powers with the powers? 3. And b to what power when I multiply that power with that power? And then b to the first is staying put. Okay, we're not done. We still have a lot more to do before we go any further. Any questions on what happened right in here? Because that's the only part that changed. Outside, this piece stayed the same and that piece stayed the same. All right, your choice, and it's totally up to you. At this point, you can multiply like bases by adding the exponents, or you can move the positive and negatives up and down. Your choice. Anyone have a preference on which one I do? Move them around? Okay, first thing I'm going to do is bring this guy to the front. What's negative 2 times negative 2 times negative 2? Negative 8? Yes or no? right? Negative 2 times negative 2 times negative 2 is negative 8. Is that negative 8 going to move to the bottom? No, because it's not a negative exponent, it's a negative coefficient. All right, what about the next piece? 8 to the third, going to the bottom or staying at the top? B to the negative 7, going or staying? I've already moved that to the front. A cubed, going or staying?
Why did it increase?
This one? Okay. The B negative 6, going or staying? Going. And B to the first, going or staying? Okay. So I have negative 8. A to what power? 6. And then B stays B to the 1. At the bottom, B to what power? 13. Okay, it's kind of getting messy. Is this my final answer here?
No.
No, because I still have what to do here? The B's. I still have to subtract. Are there more at the top or more at the bottom? Bottom. So I have negative 8, 8 to the 6, over, what's 13 take away 1? 12. And it's at the bottom because there's more at the bottom. Any questions on any of this so far? Do you guys somewhat remember this?
You know what on the top and what's on the bottom? I remember that because they're negative.
If they're negative, they move. If it's already at the bottom, they move to the top. And if they're at the top, they move to the bottom. And this, on this one here, there was no fraction. So anything that was negative moved to the denominator. So, and the signs changed. So it was that one and that one. And when they went down, they changed. Everything else stayed at the top. Got it? Okay. Next one. When we did this way back when, I told you guys when you have a radical with a fractional exponent, you put a 1 here to help you. I'm hoping you guys remember that. Adam, please turn around. So you have x to the 2/3 raised to the what power? Oh my goodness, guys, stop.
Come on.
Thank you. To the 1/6. X is to the 2/3 raised to the 1/6. Do you guys see how she got 1/6? Yes?
Oh, you have to find a common denominator.
Well, I'm just going to hold on a second because there's, I don't know what's going on back there that people can't control themselves. All right. Now, with the power to a power, what do we do? Add or multiply? Multiply. And what's nice about multiplying, you do not need a common denominator. 2/3 times 1/6. You can either cross reduce and then multiply, or multiply and then reduce. Your choice. But go ahead and work it out, whatever method you use. Or you could even plug it in your calculator. 2/3 times 1/6. Anybody have it? 1/9 is correct. X to the 1/9 power. Questions on that? We're good? All right, letter B. I'm going to change them both to be a rational exponent, and that's what it tells us to do anyway. Rational means a fraction exponent. So 6 to the 1/10 times 6 to the 3/5 or 5/3? 3/5. All right, am I multiplying like bases?
Yeah.
Yes, and when multiplying like bases, what do we do with the exponents? Add. Now that I'm adding, now will I need a common denominator? Yes. So do the common denominator or plug it in your calculator. Totally up to you. Whichever method you choose. And then add them together. What do you get?
6 and 7.
So 7/10? Is 7/10 the answer? Or is that the exponent? 6 to the 7/10. What do you think a distractor is going to be on the test? 36. Good job, guys. 36 to the 7/10. Did anybody do that by accident?
Yep.
Yep, and it happens all the time. But remember, please listen, when I said up here, when you're multiplying and you add the exponents, the bases stay the same. And I said it then for this problem. Please don't forget that. You do not multiply the bases, you just add the exponents. All right? So this here would be the answer. Be careful with that multiplying the bases. Questions?
How would you get 36?
6 times 6 is 36, and then 1/10 plus 3/5 is 7/10. All right. You're not buying it, so it's okay. We get out of class today at, guys, please stop, 22. Shh. Okay. Taking a look at the next one. What do I do when there's a power to a power? It's up here at the top. I heard somebody mumble it or whisper it. Multiply. So we have 1/3 times 2 over 1. Do you need a common denominator? No, you just multiply. What do we get when we multiply?
2/3.
So what's my answer? X raised to the 2/3. Questions? Okay. I think that top section there was probably the hardest part of all of this. Are you guys okay if we go a little faster now? Okay. Simplify. We change it to radical form. The 16 goes here. What's this index, the number right here? Is it the 2 or the 3? 2. And what's the power? Does it matter if you write the power inside or outside? No, I like it outside because it's easier to do the radical first. What's the square root of 16? 4. Is 4 my final answer? No, 4 to the 3rd, which is 4 times 4 times 4. Anybody know that off the top of their head? 4 times 4 times 4? 64. Good job. Good job, Jaden. All right. Next one. We've talked about this. Please stop the talking. We've talked about this way back when, and I just mentioned it over here. Are these two things the same? Whether I put the power inside or outside? Is it the same? It is. Is 27 a perfect cube?
Yeah.
Yep. So is it easier to square first and then break down, or cube root first and then square? It's always easier to do the radical first if you can. What's the cube root of 27?
9.
3?
Times 9.
3 times 3 times 3 is 27. Yes or no? Is 3 my final answer? No, but 3 to what power? 2, which equals 9. All right. Next one. Is 18 a perfect squared? What do we do? Factor tree. Good job. What does that break down into? 9 and 2, and 9 is, shh, guys. So I have 3, I'm going to write the 2 first. 2, 3, 3. And what comes out? 3, so 3 root 2 is the final answer. Questions? Expect any one of these problems on the test. Okay. Taking a look at number 10. What's the difference between a real number and an imaginary number? What does an imaginary have that makes it imaginary? An I. Are any of these imaginary numbers? So all the numbers are real numbers, true or false? True. Doesn't matter if they're in a radical. Radicals are still real numbers. Now, if that was I root 3 or I root 7, no, they're not all real numbers. All right, all numbers are rational numbers. False. Rational are the ones that don't have any radicals. They're like 5 or 5 over 1 or 2/5 or 3/4 or negative 1/2. Those are rational. Can these be written as irrational? No. So all the numbers are irrational. Root 3, root 7, root 11, root 13, are they all irrational? Yes. All the numbers are integers. Integers are positive or negative whole numbers. 1, 2, 3, 4, 5, -1, -2, -3, yada, yada, yada. Yes or no?
False.
False. All right. Questions before we move on? We're good? Okay. Do you guys remember how to multiply these? How to multiply radicals? Multiply the outside, multiply the inside. What's 5 times -2? What's √3 times √7? And they do not need to be like terms when you multiply. What's √3 times √7? And the only thing you have to do on the side is see if it breaks down to any pairs. What does 21 break down to?
3 and 7.
Does anything come out? No. So then you're done. This is your final answer. Put your phone away now. All right. Next one. Same thing. Multiply the outside and the inside. What's -5 times 7? -35. Square root. What's 12 times 3? Now, why would I get this one wrong if I stopped here?
Because it's a perfect square.
Okay, not only because it's a perfect square, but it can be simplified. For example, if that number was a 32, which is not a perfect square, could we simplify it by the factor tree? Yes, if it can be simplified, you're not done. Now, this one specifically is a perfect squared. Without any factor tree, what's the square root of 36?
6.
And then you have -35 times 6, which you can do by hand or plug in your calculator. And what do we get? There's no radicals. In simplest radical form means, let me show you. For example, put that away now. For example, if you had something like this, that's not simplest radical form, because what can you do with the 8? And what's 2, 2, and 2? What comes out? So you'd have -2 times 2√2. There's too many 2's on that one, which is -4√2. Not simplest radical form, simplest radical form. But if it's a perfect square, the radicals are gone. All right. So anybody have it? Negative what?
210.
Thank you. Okay. Division works just like multiplication. Divide the outsides, divide the insides. What's 6 divided by 3? Root, what's 45 divided by 5? Root 45 divided by root 5. And you can divide them because they're both in radicals. I heard it. Root what? 9. And if I left it like this, is it wrong? Can root 9 be simplified? It's a perfect squared. What's the square root of 9? 3. Remember when you take the square root and it's a perfect squared? The square root is gone. It's no longer there. What's 2 times 3? 6. Any questions? Okay, moving on. Addition is where you need to have like terms. For example, what's 2x plus 3x? What's 2x plus 3x? Anyone? 5x. The x stays the same and you add the coefficients. Yes? Is 1x plus 1y 2xy? No, they're not like terms. You cannot add them together. Okay. Biggest mistake kids make here is they treat this as a double distribution. Is this a double distribution?
No.
Well, how can we tell? It looks like it. Addition sign. When we have something like this, we distribute anything that needs to be distributed and drop the parentheses. Is there anything that needs to be distributed? No negative signs, no numbers. So can I simply drop the parentheses? Yeah. And when you drop them, it just becomes combined like terms. 8 plus 5, root 3 plus root 3. And what is 8 plus 5?
13.
Now be careful with root 3 plus root 3.
It's positive.
Root 3 times root 3 is 3 because the radicals undo each other. But addition doesn't work that way. What's 1x plus 1x?
Oh, isn't it root 3 plus root 3 is like root 3?
Okay, what's 1x plus 1x?
2x.
2x. So what's 1 root 3 plus 1 root 3? 2 root 3. Yes, there are ones in the front that we don't see. Okay, so be careful. Kids often like, oh, they're the same. They're both root 3, so the radicals cancel out. No, that's only when you're multiplying, not when you're adding. All right, I'm going to let you do this next one, but I'll start you off. 7 minus 9 root 13 because there's nothing to distribute. But what do I distribute here?
The negative.
The negative. So minus 5 And then minus or plus? Plus 2 root 13. And you can finish it on your own later. Combine your like terms. Are these two right here like terms? Yes, because they both have a radical 13. All right. Do you guys want me to do 12AB or move on?
Go ahead and do it.
Go ahead and do it. 12B. All right. I'm going to rewrite the top one. 7 raised to what power? I want you to think about what that fraction exponent should be.
Did you get 2 negative 7 through 13?
I don't.
No, no. Yes. Okay. Oh. For water. All right. 7 to the what power, gentlemen? 7 to the what power? 7 to the 5/12 or 12/5?
5/12.
And then 7 to the 1/3 equals 7 to the 1 over x. Now, what the bases are the same. What do we do with the exponents? Because it's a fraction. Subtract. We add when we're multiplying. When we're dividing, we subtract. So we have 5/12 take away 1/3. And when we take away, do we need a common denominator? Yes? All right, so do it by hand or plug it in your calculator. All right, so work it out. What do you get?
1/12.
7 raised to the 1/12. 7 raised to the 1/12 equals 7 raised to the 1 over x. Bases are the same. What must x equal?
12.
12.
Can you do A?
Yeah. Any question on how we get x is 12? All right. A is very similar. The only thing different is instead of subtracting, what are we going to be doing? Adding, because we're multiplying like bases, not dividing like bases. All right, so 18 raised to what power? 4/3 or 3/4?
3/4.
And then 18 raised to the equals 18 raised to the x over 4. What did you guys say we do here? I just asked a few seconds ago.
Add.
What's nice about adding these particular fractions?
Let's find a common denominator.
We don't have to find a common denominator because it's already written as a common denominator. All right, so 18 raised to what power? 9 over 4 equals 18x raised to the x over 4, same bases. What must x equal? X equals what? 9. Questions? All right, let's continue on to the next page. Don't forget you're doing Unit 11 tonight. Select all the expressions that are equivalent to blah, 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 blah. But, on the last page, x was it 9? Yes? Okay. Number 13. What do I do? Okay. It's asking me which one of these are the same as this. This is one of the difficult problems you guys had on the test, the one that everybody struggled with. So you just want to make sure you try everything. Okay. First thing I see, okay, there's different ways of writing this, so I'm just going to do this one first. 8x squared in parentheses raised to what power? Raised to what power? And why is it in parentheses? Because of it's all this is squared. Do you see that? All right, is that the same thing? Yes or no?
Yes.
Yes. All right, next one. 8. Okay, now this one's a little trickier because does this one have parentheses around on the fourth? No. So it's 8 raised to the 1/3 and x raised to the 4/3. Why is that? What's the power here in the 8 that I don't see? So 1/3 and then 4/3. 8 to the 1/3, x to the 4/3. Do you see that? Yes or no? If I were to distribute this exponent to see if it looks like this, there's a 1 there. 8 to what power? What's 1 times 2/3?
Wait, what?
What's that power of 1 times the 2/3?
2/3?
And then x raised to the, what's the 2 over 1 times 2 over 3? 4/3. Are these two things the same, yes or no?
Well, how'd you give that?
No. How did I get 4/3 right here? It's really small, so it's hard to show you, but I did 2 over 1 times 2 over 3. That squared times the 2/3. Thank you. That squared times the 2/3.
Wait, how come, like, okay, so like, how come you get like 8x to the 4/3? Oh, when you like multiply the exponents, and then couldn't you like, when you put it into radical form, it'd be b? Because it'd be 8x to the 4/3.
Guys, please stop the talking. Okay, can you repeat it one more time?
Okay, so when you multiply 2 over 1 and 2/3.
This right here.
Yeah, you
Uh-huh.
get 4/3, right?
Yes.
Okay.
Which is the same as this.
Okay.
But these are not the same. Okay. Guys. Shh.
But isn't it because like
Okay, so let me show you what's going on.
I get it.
8x to the 4th cube root versus 8x to the 4th with the cube root. Okay, on this one, everything here is being raised to the 4/3. Why? Because the 8x is inside what?
Parentheses.
Parentheses. Or if I wrote it like this, with the 4th power on the outside, that's equivalent to everything there being in parentheses. This, is that 4th power on the 8 or just the x? What power is here that I don't see?
1
So it's 8 to the what power?
1/3
And x to the what power?
1/3.
Do you see the difference?
How is that equivalent to the
These two are not equivalent.
no up at top?
They're not. This is this one here that I just did. That's that one there, which is not equivalent to this one over here.
Okay.
Okay? Next one. This one definitely is a trickier one to get through. And this, what time does the bell ring today?
22.
Okay, I'm not going to have time to finish it, so I'm going to pause it here. We'll continue with this block day for you guys. That's Friday. Know what you're doing. Finish this and do Unit 11.
We'll go over this on